are going to recycle that, what needs to be done is this, okay? First, you have to take apart everything by hand, separate all the components, okay? You have to sort the plastics with the plastics, metals with the metals, and even when you're sorting plastics, you have to sort it by color. And the reason is that is let's say you mix all these different kinds of plastics, and if you were to crush them down that way and boil it down that way, you would have a really weak bond of plastic that really doesn't have much of a use, except for maybe a speed bump. But if you sort it the right way, then you're able to get a stronger mold of plastic that you reuse as a park bench, as a dolly or as a cart or something useful. It's definitely a lot more useful than a speed bump.
Yeah.
So after you sort it, you crush it down, you boil it down to raw material form. Sift all the raw material and reuse it that way. Now, just to take apart everything by hand, it takes about 15 minutes. So you can imagine the kind of work that it goes into it,
yeah.
right? And after you crush it down, you also have a lot of toxins that have to be processed in a safe way, okay? Let's say, for example, if you were to switch your design so that it's meant to be recycled, cradle to cradle, instead of taking 10 to 15 minutes for each monitor, what if you could change the design so that it's 2 minutes or 3 minutes?
Yeah.
Then all of a sudden the labor goes down. Let's say you reduce the toxins that you're using in the design. Then all of a sudden the kind of special processing it takes will also be less as well. That way at the end of life it will take less labor and less processing, which would drive down the cost of recycling and make it a lot easier for people to recycle.
Yeah. Okay. So my next question is, what are the issues perpetuating the e-waste crisis?
Well, there could be a lot of issues that really are causing this big global dumping problem. First, of course, the design.